Today we are talking about lesson 21, the laws of detachment and syllogism. We have our for the first part of this lesson, we have the warm up to ignite previous knowledge. So vocabulary statement below is called a or an, conditional or inductive statement. If it is almost 8 p.m., then my favorite television show is about to start. So here we have an if and a then. That is called a conditional statement because the then part of the statement is conditional on the if portion of the statement. So this is a conditional statement. For each statement below, indicate if its conclusion is true or false. So if all the students on a school bus are athletes from a local school, then all the school's athletes are on the bus. So if one of the things that I did when I was in high school is I played on the tennis team. So boys tennis was a spring sport along with baseball and track. So on our bus, all of the students on that bus were athletes from a local school because all of the people on the tennis team were on that bus. Then all the school's athletes are on the school bus. We did not have to go to the same place that the baseball team went. So this part was true, the if was true, and the then is false. So this conditional statement is false. If the hypothesis is true and the conclusion is false, then the entire statement is false. If x minus 6 is 9, then x is equal to 15. So here we're saying this part is true. We're saying that you have a number of things, you take away 6, it equals 9, then the number of things you have is 15. So we can add 6 to both sides, plus 6, plus 6. 9 plus 6 is, in fact, 15. So this is true. Four, all odd numbers are prime numbers. So here we have, if it is an odd number, then it is a prime number. 9 is an odd number, but 9 is not a prime number. So this, our if is true and our then is false. Therefore, this statement is false. All prime numbers greater than 2 are odd numbers. So if you have a prime number that is greater than 2, then it is going to be an odd number. So for an odd number has 2n plus 1. Every odd number follows this format. So 1 is an odd number. If we have 2 times 0, that is 0 plus 1 more is 1. That is an odd number. 3 is 2 times 1 is 2 plus 1 is 3. So all of the numbers that are odd follow this pattern. So if we have a prime number that is greater than 2, that is an even number, then it has to be in the form of 2n. But if it has 2n as its form, then it's not going to be a prime number because then 2 goes into it. The only prime even number is 2 because 2 times 1 is 2. So now we've talked about conditional statements. So now we have the law of detachment and syllogism. So here are the questions that we are going to be talking about in the future. So use deductive reasoning to form a concluding statement from the given information. We're going to be using this time to learn including statement, and we're going to figure out what deductive reasoning actually is. If you want to pause and write these in notes, that would be a good idea. So deductive reasoning is the process of using logic to draw a conclusion from given facts, definitions, and properties. So when two related statements are true, deductive reasoning can be used to make a conclusion. For example, the bakery makes fresh bread every morning. It is morning. Therefore, the bakery is making fresh bread. So deductive reasoning is you have all the possibilities that you have, and you follow the rules to make it so that the amount of stuff that's left is going to be a true statement. So deductive reasoning involves using logic to draw conclusions from given facts, definitions, and properties. So two related statements true, deductive reasoning can be used to make a conclusion. So here, bakery makes fresh bread every morning. It is morning. Because it is morning relates to this part of it, then we can say that the first part is true. So here we have our statements. So we have all human beings need to breathe. Marla is a human being. So here we have if human, then breathe. Marla is human. So this is saying that this hypothesis is true. Hypothesis is true. And if that is a true statement, if our conditional statement is true, if the hypothesis is true, then the conclusion has to be true. So the conclusion that we can make from this is, therefore, Marla breathes. So we have the first part as true, and the second part has to be true. All the chess team members won their opening match in the last tournament. Jeffrey is on the chess team. So here we have if chess team, then won opening match. So now we're saying that chess team is true. Therefore, he won his opening match. J won open match. For question C, it says all the women in the royal family were wearing hats at the ball. Melissa is in the royal family. So if royal woman, then wearing hats. Melissa is in the royal family. Melissa is a woman's name. So therefore, M or a hat. All right, so now let's go back to the questions that we had at the beginning. So these are the parts that are, we're trying to get to the actual answers. All right, so we can change this into a conditional statement. So if girl on the swim team. Then left-handed. If it's a girl on the swim team, then they are left-handed. Well, Larissa, which is a girl's name, is on the swim team. So we know that the first part, our hypothesis, is true. Therefore, the conclusion has to be true. The symbol for therefore is 3 dots. Then, therefore, Larissa is left-handed. For question B, it says, when it is below 32 degrees Fahrenheit for at least a week, the pond freezes. So if it is below 32 degrees for at least a week, then the pond freezes. That is our conditional statement. It has been below 32 degrees Fahrenheit for a week. This front part is true. Our hypothesis is true. Therefore, the conclusion has to be true. Therefore, the pond freezes. Question C. If every answer on a math test is correct, then a student will get a perfect score on the test. Michael got every answer correct on the last math test. So our hypothesis of every answer is correct on the math test is true. Therefore, Michael will get a perfect score. When employees work more than 40 hours in a week. So if an employee works more than 40 hours in a week, then they get paid overtime. Dominica worked 43 hours this week. Our if is true. Our hypothesis is true. Therefore, our conclusion is true. Dominica gets paid overtime.